Yes?
All is well, sir.
Did you try to check the IP address of your home router? Hmm?
Oh, no, sir.
No? Why that? That would be a real experiment of whatever you are learning here. See what is the public IP address, what is the private IP address. So your router is having two IP addresses always. One is the public IP address because it is connected to a public network, and one is the private IP address because it is connected to the private network as well. If you remember last week we did that exercise in the packet tracer. That was the same exercise. There were two networks connected to one router. So it was like one network belongs to your home, other network belongs to your ISP, right? So that's your home router connected to your home. That's your home. That's your router connected to ISP. So this IP address here is the public IP address, which belongs to ISP, and it is giving you an IP, a range of IP addresses, or this IP address here, where it is connected to your home, it is a private IP address. In addition to this router is giving you a pool of IP addresses, and using DHCP, it is allocating IP address to all the devices in your house, which is thermostat or laptops or your mobile phones or your pads, tablets, or any other IoT you are connecting to that internet. Is getting an IP address from that router's pool of IP addresses. Why I want you to do this exercise is you can do it as a project in your class. Get IP address details of your router, see which service provider you are with. Let's say you are with Xfinity and there are other students in the class with Xfinity. Then check what is your IP address range in your house and what is theirs IP address range in their house. Okay. Isn't it? Like you might be using Spectrum. So what is there? If you are using AT&T, what is there? If you are using T-Mobile, what is there? So this is a very good exercise. This would be a very good exercise. Now, after doing this, you can identify that are we using same range of IP addresses for private IP address or it's different? Range of IP addresses. For let's say for David's home and for Sam or for Sam's home, is the IP address range same or different? Or if they are using same service provider, if you are using different service provider, then also you can check if the IP address range is same or different. What is your subnet mask? Check. What is the subnet mask? Okay, what I'll do is I will create an exercise for this, and then only you guys will do it. Okay.
Mr. Sandeep, sir, what's today's lesson about?
What is?
Wireless networking?
What is?
Is today about wireless networking?
Okay. If you are already there in the lesson content list, then yes, it would be. So last week we talked about cabling. Now we'll talk about wireless network. But before that, let me see if you guys are doing your labs and quizzes regularly. Tuan? Are you here? Are you Tuan? Tuan Tran? You have not completed your packet tracer? Huh? Okay. Well, when you are expecting this, when I should expect you to submit that? See, I'm not enforcing anyone. That's all. Only reason I'm asking this to you guys is that I want you to pass this semester successfully with good grades. That's it. Rest, whatever you do, I don't. It's your life, your career, your future. Some of you are doing way ahead than scheduled. Some of you are most of you are on schedule. Some are not doing at all. They are kind of, I believe they must be dropping out of this class or they have dropped out already. But that's fine. Those who are regular, I want them to do all the activities regularly, all the quizzes, activities, labs, everything. You are a sincere student if you are here regular. Otherwise, rest of them are enjoying and doing at home. But that's fine. Alright, I see it now. Let's go back to the lessons. And today's lesson is on wireless networking. Okay. So what we have in the wireless networking, so there is a read, then there is a watch. Create and secure a basic wireless network in packet tracer. So I believe those who were there last week and doing exercise or activity with all of us, you are now comfortable using packet tracer application. I want you to watch this exercise and activity and do this. If we get time today, before the end of the class, maybe we will do it here in the classroom, otherwise you will be doing it. This is the PowerPoint, I will be using it in a minute. And these are the other assignments we have in this, like we have a simulation where we are supposed to configure, a SOHO. What is SOHO stands for?
Small office, home office.
Small office, home office. So it's since we have started working out of home, this term becomes so popular. SOHO, small office, home office. And then you have another simulation which is on modifying SOHO router wireless setting. Now this activity is kind of simulation of your home's router modification. Whatever you are doing here is going to reflect what your home router may look like. And remember every home's router has an operating system. Last week you have seen those switches and routers in the back room, isn't it? Yeah. Every device, whether it is a switch, is it a router, it is a firewall, it is a home router, these Wi-Fi stations, everything is, or these projectors, they all are having an operating system in it. And that operating system, sometimes we call it iOS, not the one which is there on Apple phones. The one is iOS or NOS. iOS and NOS. Try to find out what it is, what they do. Okay. So these operating systems are required, or they are there, and they also provide you an interface. When I say interface, it's like an application on browser. An application on browser and using a particular IP address. Sometimes it is this 192.168.0.1, sometimes it is 192.168.11. That application is always tied to an IP address. The moment you put this IP address in your browser, when you are connected to the same network, you will get that application on your browser, which is basically the application connected to that wireless device, this device or the device at your home.
So the projector has an IP address then?
Yes, definitely. It can have an IP address as well. This has an IP address also, right? And even any device which is showing you that it is capable of connecting to a Wi-Fi. Sometimes in our houses these days we have all the appliances capable of connecting the Wi-Fi. Have you ever noticed? Your refrigerators are doing that, your dishwashers, your washer dryers, your exhaust hoods in the kitchen, sometimes microwaves. These all are IoT devices. Your thermostats, right? Your security systems, your security cameras. They all are IoT devices. They all are connected to Wi-Fi. And if they are connected to Wi-Fi, they are having an IP address. Now, who makes it connecting to Wi-Fi? Then that means there is an operating system. Even if it is a small camera which is installed somewhere in your house, is having an IP address or connected to a Wi-Fi, that clear indication that this camera has an operating system. Now, the size of that operating system or application of that operating system could be different. What does it mean? For example, if I'm having an operating system in refrigerator, then that operating system is doing much more work than an operating system I have in a camera. Because for the camera, I just need an IP, I need very few functionalities in this device where the device can get an IP address and can connect to a central station. Can transmit the videos, to that central station so that you can watch those videos either on your phone or on some console. Whereas a refrigerator needs to do more work than a camera, because a refrigerator may not have a camera, it may not be transmitting any video, but it is showing you some weather alert, weather updates, current temperature, humidity levels in your house. It may be holding the inventory list in whatever you have inside your refrigerator. So it is doing much more than what the camera is doing. Just imagine what doorbell is doing. If the doorbell is having an IP address and what the doorbell is doing or what the thermostat is doing. So based on the functionality of the device, we can modify this operating system, and whatever it is always based on Linux. It's always based on Linux. So Linux is a kind of an operating system which you can tweak, modify according to your requirement. Somewhere we have keyboards, somewhere we have touchpads, somewhere we have nothing. Means no keyboard, no touchpad. Like your security cameras, no keyboard, no touchpad. So do you need all those? So whatever we have, a hardware is now a module. It's like a Legos game. I'm sure everybody knows about Legos here in this room. So your operating system is like a Legos. You have a base. There is a base. On top of it, you are putting whatever you need. So on the base, you need a keyboard. So keyboard module is added. You need a mouse module is added. You need a camera. You need a sound. You need microphone. Depending on what you need, you can add the module in your operating system, and then it will work accordingly. Okay. So things are pretty fascinating here in this world. The only thing is how much we know. Alright, so you are going to do this simulation activity, and I would say that after doing this simulation activity, be a responsible member of your family. If you want to try to access your router, that's fine. Don't make modifications, otherwise you may end up disabling or messing up with your router. Maybe trying accessing it, see what is there. If you want to play around, that's up to you. I'm not giving you any ideas. Okay, there's a live LVML or the lab where you are going to look at the troubleshooting tips of network. Then you have wireless networking exercise, and then another scenario-based exercise on quiz. All right, let's look at the PowerPoint. See, last week we downloaded one presentation, but it's not here anymore. Because why? Because these systems are kind of reformatted every week. Alright, so these are the chapter objectives. We are going to talk about the wireless transmissions and looking at the standards and innovations happen in this wireless network. Planning a Wi-Fi network, securing a Wi-Fi network, and troubleshooting a Wi-Fi network. Some characteristics of Wi-Fi or the wireless transmission, so you can just read this from the chapter. And again, I would encourage here, and I'm encouraging every student in my classes, that use AI to enhance your learning. Okay, don't just, but obviously there is always a different way of using AI, ethical and unethical. So that it depends on you. Because if you are using your AI ethically, then you are learning. If you are using AI unethically or for something, let's say pass a quiz or an exam, then it is cheating or unethical. It's up to you. We can't just stop everyone to use AI or AI tools to pass the exam. If you are taking quiz at home, no one is watching you. If you are taking exam here in the classroom, definitely we are here to observe what you are doing. But take help from AI wherever it is possible. So, remember that I told you one day that data does not travel on its own. Data doesn't have legs. Data cannot walk, cannot run, cannot fly. It doesn't have wings, doesn't have legs. So how does data travel from one place to other place in Wi-Fi? Channels, okay. All right. What else? Huh? Piggybacks? Piggyback of what? What type of signals? Saying something, someone?
Frequency.
Frequency. Whatever you are talking about are the characteristics of radio waves. Radio waves. Alright, so frequency, radio waves has frequency. Radio waves are having signals, or they send signals, radio waves or radio transmitters. So these are the transmitters, and our devices are the receivers. Okay, and everything works on frequency, what you are saying. So frequency is how two devices can communicate. This is a transmitter and this is a receiver. This transmitter is sending signals. Then how this device knows that I'm supposed to receive these signals? Because there are multiple devices in the room. Some are receiving signals, some are not. For example, you are visiting your friend's home. your the Wi-Fi in your phone is on, but it's not connected. It's not connected. Why it's not connected? Why the other's device is connected? Why yours is not connected? So you have to synchronize your device, your receiver with the transmitter, so that receiver can receive the signals from the transmitter. Whenever you are, these all are sending the signals at the same frequency. Some devices are connected, some are not connected, because some devices says that search for the signals coming from a device named this with the credentials. These are the credentials. You provide your user ID and password. So in other cases, some devices where the user ID password doesn't require, they are supposed to synchronize on same frequency. Have you heard this? You must be using this radio, FM radios in cars. Mostly cars are using, we are using FM radio in cars. Otherwise, no one is using FM radios. There was a time when we used to have FM radios almost in every home, or for a brief period, we were having FM in phones also. But not anymore. That's fine. But why two devices why one device can receive the signal from some FM, or when you change the channel, you change the frequency. So it is like when you are on the same frequency, then you can receive the signal from a transmitter. You are using walkie-talkie, so you change the frequency of your receiver device so that you can match with the frequency of sending device. So transmitter is transmitting at 60 megahertz, but you are on 55 megahertz. You cannot hear this voice, or you cannot receive these signals. You can only receive these signals when you are also on 60 megahertz. So when you match the frequency, when the transmitter and receiver matches the frequency, they receive or they can talk to each other.
So it can't be greater than 1 megahertz of difference?
Yeah, they can be what?
Like if it's 60 and 61, it would not be
It will be, but there may be some interferences.
okay.
Right? There will be some interferences because there is always a, when you talk about all these things actually, there is always a buffer zone. So if this is my 60 megahertz channel, if this is a 60 megahertz channel, so there is always a buffer zone of maybe 1 or 2 megahertz on either side. On either side, there is a buffer zone in which if you are there, you can receive the signals, but they may not be very clear. You are right there, but you are not getting complete signal, you are getting some noise. Along with the voice, you are getting noise.
Is the buffer smaller for AM radio?
Could be. I'm not fully sure about that, but it could be. Okay. So my point of saying is that you can receive, or you are receiving signals because you are matching the frequency with the transmitter. There may be multiple transmitters with the same frequency, but you are not connected to all of them because of the credentials issues. For example, your neighbor's router. If you try to search Wi-Fi connections at your home, you get more than a dozen of Wi-Fi names in your list, in your phone list, right? Phone Wi-Fi list. But you cannot connect all of them. You can connect only your home router because of the credentials. So now we are also having this another layer of connection protection, which is credential. So one was the frequency. Okay, I'm matching the frequency, but can I connect to all of these? No, you can't. You can connect only to certain channels or certain connections because of authentication is attached to it. And that was added in the wireless transmission in internet because of the security reasons. Now we are transmitting a lot of data over the Wi-Fi signals or Wi-Fi communication channels that requires security as well. So, and now we have something called wireless spectrum. So, wireless spectrum is the range or the frequency range of electromagnetic waves used for data communication. So, from this range to this range, like from 60 megahertz to 65 megahertz is used for this purpose. And generally, defense department in every country, defense department in every country manages these spectrums, because they always keep certain spectrums for themselves. For is, I would say the government is doing that. So government has many departments who wants to do secure communication with each other. So they keep these spectrums reserved for themselves and releases spectrums for general public use. You must have heard about the 2G, 3G, 4G, 5G, 6G, right? What are these? These are the mobile communication technologies, right? These are higher bands. We are going into higher and higher bands, or faster and faster bands. So right now, which type of technology we are using? 5G, right? So you can check on internet like what is the frequency band or the spectrum range for 5G, and now we already started talking about 6G, which is coming in future. What will be the spectrum band for 6G? Or the government agencies are already using those frequencies, but in order to provide the higher speed to the general public, they may switch to more higher bands in future, and they release those bands to the general public. So there is always a spectrum required, and within that spectrum your devices communicates with each other. I don't know why they created these pictures for such a small size. Now you can see these are the various frequency ranges and their usage where we are using. So RFIDs. How many of you know what RFIDs are? RFIDs. Contactless cards, right? And in the like you are these days, it is very much used in your credits and debit cards. In some cases, the shops are having those tags attached to the clothes or the items you are buying. So the at the checkout counter, first they need to remove that tag. Or in some cases, those RFIDs are so smart that you don't need to remove it, just need to scan. The moment you scan it, it is cancelled. Cancelled means the RFID will cancel, and you can pass out. You can pass from the security gates of that shop or the store. But otherwise, if you do not scan the item you purchased and you are exiting out of the store, then it starts making, or it sounds the alarm, right? And it alerts the shopkeepers or the stores employees that someone is trying to take out some item without scanning or paying the amount. So RFIDs are very small. They are using very low frequency or low spectrum, which is 100 kilohertz. Then you have 1 megahertz, which is AM. Then you have shortwave radio, which is from 1 megahertz to 10 megahertz. Then you have FM on 100 megahertz and more. Then you have cellular data. Then you can see cellular is coming in at various levels, depending upon what type of channel you are using. Then Wi-Fi, Bluetooth, and all those communication channels, C-band, satellite, Wi-Fi again. So all these are the spectrums controlled by the government, and they release these spectrums for different uses time to time. Now the channel. So every communication medium can have multiple channels in it, right? Same satellite communication, what you are receiving in your TVs at home, you can watch multiple channels in it. Same internet connection, you can watch multiple app-based programs in it because of different channels. They are using different channels, and channels are basically the frequency hopping spread spectrum. Channels are basically a range of, again, the spectrum. Within the spectrum you have created narrow streams of signals. And there are two types of technologies we are using here. One is FHSS and DSSS. So when you read your chapter in more detail, you will find more information about it. If I start talking about it, then it will take a lot of time here. Wi-Fi uses DSSS and Bluetooth uses FHSS. So we need to remember certain things here. Just the terms would be enough. And this picture represents how the channel is created in same frequency. For example, the frequency is 20 megahertz, the same, but there are multiple channels created based on their strength. Antennas, I'm sure you know what antennas are. So wireless signals originated from electrical current traveling along a conductor. There are various types of wireless channels. One is some certain wireless channels or wireless signals. Wireless signals are where they always, we can say it is insight signals. Means unless your transmitter and receiver cannot see each other, they cannot talk to each other. So means your transmitter and receiver, they must be in the line of sight. Then only they can transmit the signal and receive the signal. Other type of signals they are just broadcasted. Okay, I broadcasted the signal, and now it's up to the device whether it is receiving the signal or not receiving it. For example, your mobile phone connections. For example, your Wi-Fi connections, college, home, offices, stores, and anywhere, your Wi-Fi connection. Your Wi-Fi connection is always broadcasted. Your mobile connections are always broadcasted. But your microwave connections, the connections which are based on microwave towers, or we call them microwave connections, they are always in line of sight connections. You must have seen a lot of high towers having one antenna like this, and there is another tower at some distance facing towards the same tower. So why we are having the tower, why we just can't broadcast the signals and they catch each other? Because you know that Earth's surface is like this. Earth's surface is like this. So you have to erect a tower or raise a tower so that you can come up with a line of sight connection between the two towers. You are having a lot of interferences in between trees, houses, and other things. So you have to cross all those interferences as well, so that you can have a line of sight. The other type of signal is it's broadcasted, the signal, in all the directions. In all the directions. Your radio signals are broadcasted. Your mobile phone signals broadcasted. Your Wi-Fi signals broadcasted. But these are some direct communication or point-to-point communication where line of sight connections are created. So antennas are also required in some of the devices, and you may say that where is the antenna of this device which is on top of your head? So some antennas are now hidden these days. They are there, but you can't see them. Antenna is not like some stick is coming out of the device and standing tall. Okay, this is the antenna. Oh, no. Antenna is just an electronic component which is receiving signals or sending signals. So it is not necessary to be a stick or a pole or a tower like that to coming out of the device, but it can be anywhere inside the device. Now these days, because earlier antennas were not having very good strength, that's why we used to have a small unit coming out of the device, but now it is all. You must have seen old cars. In old cars, there was an antenna coming out of the car to receive the radio signals, but not anymore. Where those antennas are? So the devices, the receiver becomes more powerful, so that we don't need any external unit to receive the signals. Right? So at the destination, another antenna accepts the signal and the receiver converts it back to the current. Now listen, as I'm saying that data cannot move by itself or voice. Let's say I'm broadcaster, so my voice cannot go after a certain distance. Like if I'm speaking here, maybe the person sitting at the last bench can hear me, but not the person sitting at the end of this hall, because voice cannot travel for long. But if I'm using some microphone, if I'm using a microphone and this microphone is connected to a speaker, then and a speaker is placed at the end of the hall, everybody can listen me, isn't it? So what I'm doing, I'm converting my voice into current, sending it to the speaker, and the speaker is converting that current back into sound or voice, isn't it? So current, what the current doing here? Current is like a carrier. Current is a carrier of my voice. So I modulated my voice on current, means loaded my voice on current. So as my voice modulate, means my voice having a pitch, my voice is going up and down, what my words are having different wavelengths. So all those things are now imposed over the current. And what the speakers are doing, speakers are basically taking that current and converting the current back into the sound form. That's what the diaphragm on the speakers is doing. These days the diaphragms are much advanced, they are digital. In early days, if you have seen any old speaker, that speaker has a membrane which is kind of vibrating when the sound is producing. When the speaker is producing sound, that membrane is vibrating accordingly. Now the speakers are digital, so that's not anymore. But the voice can travel for a long distance, not very long, but for a long distance. Same as with the data. Data is bits and bytes, right? Data is nothing but the bits and bytes, off, on, off, something like that. So now we are using radio signals or microwave signals, and we transposing or loading these bits and bytes on those signals and sending them over long distance. So this process here called modulation, and when it reaches at the receiver end, it is going to extract these off, on, off code from that radio wave or microwave signal, and this process is called demodulation. So modulation, demodulation is happening on both sides. That's what your modem is doing. That's what the modem is doing. Modem, M-O-D-E-M. So DEM is demodulation, MO is modulation. So every modem is capable of doing modulation and demodulation at both sides, because any device can be sender or receiver at the same time. You are sending as well as receiving. When you are making request for some data, you are sending signal. When you are receiving the data, you are receiver. So you have to convert the signals back into the data. So that's how the data modulation, demodulation, and carrier and all that things works. So this is all explained here. Now directional antenna, which is unidirectional antenna and omnidirectional antenna, issues wireless signals along a single direction. That's what I was talking about. Line of sight connection. Only line of sight connections are possible. So for sending the data over a long distance, these towers, so there are series of towers. So if this is my earth, let's say this is the earth surface, so a series of towers are created or installed on the earth surface so that they can send signal to each other and can establish the communication over long distances. Now we have satellites, so we are not using these towers a lot. There was a time when we were not having satellites or not too many satellites. So, and these type of towers were the only way of communication over the long distances. But now we have satellites, so we just send the signals to the satellite, and then satellite redirect the signal back to Earth in whichever position or location you want. Signal propagation is referred to way in which a wave travels from one point to other point. LOS, which is line of sight, I told you, occurs when the signal travels in straight line directly from transmitter to receiver. And when obstacles are in the signal's way, the signal may pass through the object or be absorbed by the object. For example, these walls, even the voice can pass through these walls. I'm speaking here, any person sitting on the back side of this wall can hear me, whatever. So all these signals can also pass through these walls. That's not a problem. But if you have a concrete wall or a iron wall, a wall made up of concrete, a hard concrete, or made up of iron, then it is difficult. Then it would be difficult that signals cannot pass through those walls. So sometimes we create such rooms in secured facilities. We create such rooms where no signal can penetrate. No Wi-Fi signal, no wireless signal can penetrate in those rooms. So in some cases, especially the electronic evidence, the rooms where the electronic evidence are kept by security agencies like police department or FBI or something similar. If they have that electronic evidence, so they are keeping those evidence in a box or in a room where the signals cannot penetrate. Okay, so if you are in the cyber security, then you must be reading it or studying it later, that how we can protect electronic evidences. So signal propagation attenuation, the farther the signal moves away from the transmission source, the more it weakens, and it's a very common phenomenon. So wireless signal can be amplified by increasing the power of transmission. So whatever we were talking about, let's say we are sending the signal to the satellite. So here is the satellite, and we are sending that signal from one corner of the earth to the satellite. Satellite receives the signal, amplify the signal, and send it back to the earth. Amplify the signal so that it does not lost in between or does not lost in the transmission. So this type of amplification. This is the case of satellite, but it happens in otherwise also. We were using amplifiers in our music systems long back. So if my music system cannot produce very loud voice or loud sound, then I can connect an amplifier to my music system, and then I connect the amplifier to the speakers, and I can hear the loud music. So amplifiers are basically increases the strength of the signals. Fading is another issue. As signal runs into obstacles, its energy will gradually fade. Interference, electromagnetic interference, it's a lot these days because we have a lot of open transmission lines across the city or country. Signal to noise ratio, or SNR, is a proportion of noise to the strength of the signal. How much noise is embedded into my signal? Now here noise doesn't mean the noise of voice. Okay, we always consider, or it's a very general understanding, that noise means all the noise of vehicles running or wind blowing, all those noise. No, it's not that noise. Noise is electronic noise. Because if your data is or your signals are traveling in a wire or traveling in a wave, then what kind of noise can get into the signal. It's all electromagnetic noise. It's all electromagnetic noise which you cannot see from your eyes or cannot hear from your ears. It's all, for example, sometimes our signals, or when we listen the voice, there's an interference in the voice. It's not very clear. Distorted voice, or voice coming at some gap, or words are not continuously, you are not hearing the words continuously. So those kind of interferences are caused by the electromagnetic interference. It's not that if my wave is traveling and a plane is, let's say a plane is passing and wave is traveling, the noise of that plane get into the signal. No, not like that. Yeah, but it may be possible that there are waves and lightning strike, or there is a thunderstorm passing by, and because of that thunderstorm there are interferences in your signal. Very much possible, because the thunderstorm is producing a lot of lightning, and because of lightning there may be some electromagnetic interference in your signals. Right? Yeah. So you can hear a lot of static in your signals, in your voice. Sometimes you say, oh, I can't hear you properly. Can you speak a bit louder, or you can come out of the space or something? There are other signal propagation issues like refraction. When a wave travels through objects, right? It is like wave is, all kinds of waves have different characteristics. Some waves can travel through these type of walls. Some waves can travel even through the cement or concrete wall. Some waves can travel even through the iron walls. Depending upon what communication channel it is, or what type of communication it is, how much cost you can bear to use those type of waves, you can use those waves to transmit your signal. Like you want to send a message to your friend, you have 3 ways to do that, free of cost. Using your mobile phone, you can send a message to your satellite phone, right? Or you can send a written letter to your friend. What method you will choose, it depends on the importance of that message, the value of that message, right? If the value is high, then only you will use a very costly medium to send the message. If the value of that message is so high, so important, so I would say sensitive, like the government departments are sending messages, or let's say 2 military teams are sending messages to each other. So they may be using a very highly secure channel, which is always there, no one can intercept it. So depending on that, you can choose your carrier wave. What carrier wave or carrier on which you are sending your channel or your message. So it can travel through all kinds of obstructions, or it can travel through only certain types of obstructions. Reflection. So wave can also encounter an obstacle and reflects or bounce back towards its source. So we need to identify those type of interferences as well, and need to identify which wave or which type of wave can pass through all kinds of obstacles. Scattering, which is very common in wireless signals. Diffraction. So these all are the possible challenges we are facing in any kind of wireless communication. But again, let me tell you one thing, that as I'm talking here, so these waves, there are different waves available, and as I said, depending on what is the value of your message, you can select your wave, right? For example, you want to send a package to your to some friend living in a different country. There are 2 ways to do that. One is you can ship it by air, you can ship it by sea. If you are shipping it by air, it will cost you more, but it will take less time. If you ship it by sea, it will take more time, but it will cost less. What is more important for you? time or money. Based on that, you decide what mode of communication or what mode of transportation you will use. We always prefer to go by air instead of going by ship, because it is taking less time. Obviously, it takes a lot of more money compared to ship. But these days, even ship is not so cheap. Now, this is your standard 802.11 WLAN standard. So every time you are or we are communicating on these network channels or different types of network mediums, we are following a standard. For example, on internet, we are following TCP/IP protocols and Ethernet standard to communicate. Similarly, in wireless LAN, we are using 802.11 standard or suite. It's a group of standards, and as we have, like, every law has clauses and subclauses. There is a clause, there is a subclause. There is a clause A and there is a clause AA, or there is a clause B and there is a clause B and B1, something like that. Similarly, this standard 802.11 is a big group. See that? Here. Look at this. 802.11 B, A, G, N, A, C, A, X, B, E. All those are sub-standards we are following in different media or different types of communication devices. These are some notable Wi-Fi standards. And all these standards are basically depending on what type of devices you are using for communication. Let's say you have those cameras, the action cameras, what you can put on your head, what we call them, GoPros. A GoPro is a type of camera, but otherwise, it's a GoPro is a company. But what type of cameras are those? Or you can say dash cams in your car. So those cameras are communicating with your phones. Let's say connected to your phones. So they are using a different standard for that. Your phone is connected to this Wi-Fi, is using one other standard. Your laptop or desktop is using to this Wi-Fi, is using a different standard. So every device communicating to other device is following a particular standard. Depending on what kind of data the device is transmitting. For example, it is a GoPro camera, so it is only transmitting you the pictures, videos, and voice. But no document, no PDFs, no docs, nothing. But in case of phone, you need to talk to someone, it's a live call. You need to transfer the phone, photos, videos, voice. You are supposed to access the internet, get the data, upload the data, document sending, sharing, lots of chat applications you are using. So many things you are doing. So their way of communication is different than other devices. Your watches are having different set of data to be transmitted over the network. So every type of standard, and similar, like Bluetooth is one type of wireless connection. Do you know any other type of wireless connection other than Bluetooth and Wi-Fi? It's very common. Huh? Can't hear you. Remote desktop is not going, it is using one of your network only, right? It is not the type of connection. I'm talking about like Bluetooth and Wi-Fi, there is another connection or another communication we use or for the data transmission. VoIP? No. VoIP is voice over IP. So you are using what is existing channel is. NFC. What is NFC? Right. So what it does? It is communicating only to a very close distance. Communicating at a very close distance. Now you are using your remote TV remotes or any other device remotes. It is also using a wireless connection or Wi-Fi or not Wi-Fi, wireless. Every device is using a set standard only, and they're making those devices following these standards. So you need to know, or we need to know that this standard is used by what type of device or devices. So 802.11 frames are divided into following groups: management frame, control frame, data frame. So data frames are one of them, and it is something like, if you have seen or studied IP packets. Have you studied IP packets? In the previous chapter we had IP packets. In the IP packets, your data frame is one part of it. Apart from data frame, lot of other information is attached to your data packets. So similar here, your frames are having different, there are multiple frames. One is your management frame, control frame, and data frame. So what is the role of each type of frame mentioned here? That's the data frame. So showing you everything about. So it's your data, then followed by all other information. That's your Ethernet frame. Ethernet means your normal cable-based network communication. So you can compare the difference between your network frame on Wi-Fi and the frame on wired communication channel, where the standard is 802.3 or the standard is 802.1. So this is your Wi-Fi data packet, and this is your regular network data packet. You have more information attached. Just consider it in this way, like whenever your data signal passes through a device, whenever, in case of normal computer, it is passing NIC, it is going to switch, it is going to router, it is going to another switch, it is going to another NIC. I'm talking about communication between two computers. In this simple communication, your signal is passing through 1, 2, 3, 4, 5, 6, 7. 7 different devices. Every device is putting a signature to your communication packets. Every device. Here, application, it is putting its own ID. Here, MAC. MAC is adding, this NIC is adding MAC information. Switch, every switch has its own ID. Every router has its own ID. And then every message also contains the destination. So destination is this NIC here, and that application. Then it keeps going through this, adding. So every time it is passing through a device, the device is adding its own signature. If it is passing through n number of devices, it is going to have all those signatures attached to that message. The message always gives a space. A message always contains a space where other devices can attach their information. So that is how security agencies can track from where the communication was originated. So when you are going to do cybersecurity studies, you are going to study that part as well. Have you ever tried opening the signature of your email? Every email contains a very long signature, and that signature contains all the information about the channels the email message passed through. Even you are sitting here on this computer sending an email to someone, so that email contains or carries the signature of this laptop, this desktop here. And a receiver can examine the signature and can get to know the person was sitting on this computer at this time period, send this email to that person. So it's not that easy, or it's not that simple when you look at your email message that it only contains the text. I'm not sure if the Outlook will show that, but I'm still trying it. know, it is not showing. But you can see this type of thing, view message details. And I'm just showing a very simple thing which everyone can see. But there are other things which are completely hidden behind this message which you can see only with the help of specific tools. Okay. Oh, here it is. See that? This is the message detail hidden. What you can't see when you are looking at your message. A lot of information attached to every email you are sending. Received from. What is that ID means? I cannot say right now, but this is an IP address, IPv6 address. Received from. So multiple receivers are in between. Means in whatever channels or whatever devices this email passed. This email passed through different servers also. So it has contained all the information, authentication details, and the encryption signature. This is because all these communications are encrypted these days. So that's the encryption signature and the application details. So I can understand, or there are tools available online or even in forensics, computer forensics, which can decode this information for you. Means you copy this and pass this information to that software, and the software will tell you what it is. So it's a very fascinating thing these days on internet. So you should be very careful. So Wi-Fi access method. So it is basically using now uses ACK packets. Now I'm sure you know what is ACK means. What is ACK here? Acknowledgement, to verify every transmission, and requires more overhead than this, because every packet is using one acknowledgement. So whether it is a management packet, whether it is a control frame, or it's a data frame, it is going to need verification. RTS, CTS, or request to send, clear to send protocol ensures the packets are not inhibited by other transmissions. And here the picture represents how this entire communication happens. So sender and receivers talk to each other based on. Now what is this CSMA and CA? Okay, now let me tell you one thing. There are two technologies we are using, CSMA, CA and CD. So there are two things we have, the difference between CSMA CA and CSMA CD. So this is your collision avoidance. Carrier sends multiple access. Carrier sends multiple access with collision avoidance and collision detection. So CSMA CD and CA are the two different communication technologies, because these days we are using same channel for both ways of communication, two-way communication. So it is like when you are driving on a road which has no two lanes. There are no two lanes. You are driving on one lane, and incoming traffic and both side traffics are going like this. So you have to avoid. Now just imagine you are going on a road, and it's a two-way lane actually, but one lane is closed for some construction work. So what happens is, this side traffic uses the lane like this. So you must have seen some person is standing over there asking you to stop. So you stopped here until all the traffic from the other side pass. You are waiting, and then when the road is clear, then you go. What you are trying to do? What you are trying to do? Collision detection or collision avoidance? Avoidance. You are doing collision avoidance. The detection is when this lane is is open for all the traffic. All the traffics are going by their own will, and you are trying to adjust in the same lane with the other incoming traffic. So it's basically collision detection and avoidance works in these principles, that I'm trying to detect the collision and or I'm trying to avoid the collision. So read about it. Read about it, and this type of technologies are used in the mobile communication also. Your mobile phones are working in these technologies as well. You must have seen Verizon. Do you know that Verizon services are different than AT&T services? How? Based on these two technologies, their services are different. So just study a little bit more about it if you are interested, and otherwise not that important. Wi-Fi association, so is a process where the packets are exchanged between the computer and an access point in order to gain internet access. So it is like trusting each other. So your device is trusting the Wi-Fi device or communication device over here. Scanning occurs when a wireless device surveys its surrounding for an access point. So the moment your phone comes into this network, it starts scanning. Who is there? Who is there? Who is there? And it is always having a credentials or authentication available for one network only, so it connects to one network. It does not connect to all the other networks. Same happens with your home. When you go back to your home, your phone is automatically connected to your home network, but not to your neighbor's network, because the authentication settings are available for your home network only, so it automatically connects to your home network. So there are two types of scannings here: active scanning, passive scanning. Just read about it. SSID is always there, service set identifier. SSID is a unique character string identifying an access point. What is the SSID connected here? What is the SSID of this network? Anyone? What is the SSID of this network? GTC Wi-Fi? Yeah, it is GTC-Wi-Fi. That's the SSID of this network. Do you know what is the SSID of your home network is? So that's how you know what is SSID. Now that SSID is identified by us, by humans. We can understand that, but computer doesn't understand that. So computer always having their own numeric ID compared to your physical ID. Now the wireless topologies. Now topologies are always means to how your devices can be in, where the devices are located in the network. Are they located in a proper pattern, or they are located anywhere in the surrounding? So one is IBSS, which is independent basic service set. It is a ad hoc topology where small number of nodes closely positioned transmitting directly to each other. So it is something like your phone, your watch, your Meta glasses are connected with each other. Then basic service set is your infrastructure topology. A group of stations shares an access point. So like group of stations where we have multiple phones connected to this particular device here. Then ESS, extended service set, is a mesh topology where the several access points are connected to the same LAN network. Now every classroom has this device installed. Two of them, right? One is here, one is on that corner. Every classroom has this. So these all devices are connected to the same network, and they are creating a kind of mesh topology. Mesh means where anyone can be anywhere. Similar to your mobile network. your mobile networks are also creating a mesh topology where any receiver, any phone can be anywhere in the network. Alright, so this is the example of these wireless topologies. Then you have this band steering. So just read more about these things from the chapter. Yep. So this is the knowledge check I already asked. So this is your answer for the question. Which type of identifier allows wireless clients to roam freely from access point to access point? It's ESSID, or which is basically a part of mesh topology here, ESSID, or extended service set. Now, because when you are moving in from one building to other building here in this college campus, or when you are roaming around the city, you are never connected to one tower or one access point. You are connecting to multiple towers, but always at one tower or one access point. Your device is not connecting to multiple access points or multiple towers at the same time. So how this switching happens, seamless switching, because you are watching a video and you are moving in a car. Have you ever seen any glitch or any interference? Signal is not there at all, it's something different, but otherwise, for a short distance, you never see any discontinuation in your video. Continuously you are watching that video while you are moving in a car. That is possible because this seamless switching of connections from one tower to other tower, and you never get to know that I am now connected to a different tower. Same as with these devices. You are going to building A, you will no longer be connected to this device here. Or if I go back to my room where a different Wi-Fi transmitter, my phone will be connected to that Wi-Fi transmitter without any disconnection. So this is your ESS, or extended service set. Okay, let's take a break here for 10 minutes and then we will continue.